we're learning about how to solve the circuit using node analysis. So the first step in solving the circuits using node analysis is to identify the node. And we have this node and we are labeling it as A, node A. And let's suppose the voltage at this node is voltage at node A, VA, right? So first is you need to label the currents. So let's suppose current in branch for 6 ohm resistor, I am labeling it as I1. Current in the second branch, that is 4 ohm resistor, I am labeling it as I2. And current that flows in 2 ohm resistor, I am labeling it as I3. Now, as per KCL law, that is Kirchhoff's current law, the current entering into the node should be equal to current leaving from the node. So whatever current is entering into the node should be same as current leaving from the node. So at node A, what current is entering? So the current entering is I1 at node A. And current leaving from node A is I3 current. And current leaving from node A is I2 current. So we have to write KCL equation representing like whatever current is entering into the node should be same amount of current leaving from the node. So that is KCL law. So we have written this equation. The next step will be you need to identify the values of I1, I2, I3 in terms of voltages. So what is I1? I1 is the current that flows through this resistor here, 6 ohm resistor. So that is I1. So the current that flows through 6 ohm resistor is I1. So using Ohm's law, current is equal to voltage divided by resistance. So what is the voltage drop across this resistor? So voltage drop across the resistor is voltage at this point minus voltage at other end of the resistor. So like when you measure the voltage, you put the multimeter at one end of the resistor and then positive end of the multimeter on one end and negative on the other end of the resistor to measure the voltage. That is called voltage drop. You are measuring how much is the voltage drop across the resistor. So voltage drop across this 6 ohm resistor is voltage at this point minus voltage VA divided by resistance 6 ohm will be I1. So current I1 will be represented by, so the voltage here is plus 12 volt because this is positive. So voltage at this point is plus 12 volt. Voltage at A point is VA. So I will say you have to take the direction in which the direction of current. So current will flow from higher to lower potential. So it's going from 12 volt towards VA. So we will take 12 minus VA divided by resistance that is 6 ohm. That gives me I1. Now to write I2, it will be, so I2 is the current flowing through 4 ohm resistor. So that means you have to take voltage drop. So across the 4 ohm resistors, the voltage at A end and voltage at this lower end that I label it as B. So what is the voltage difference between the 2 points, A and B? So this is considered as ground in DC. So voltage at A end is VA minus 0 divided by 4 is the resistance. So you are going in the direction of current. So VA minus 0 divided by 4 ohm gives me current flowing through the resistor. Now I3 will be, so I3 is the current that flows through 2 ohm resistor. So voltage at one end, that is at point A, and then let's suppose this point is C. So A and C represent the two ends of the resistor, 2 ohm. So voltage at A point minus voltage at C point divided by 2 gives you I3. So what is voltage at A point? So I will say VA minus voltage at C point. Now if you see here, this is negative. So this small bar represent negative. So that means voltage at C point is minus 6 volt, right? So it will be VA minus of this voltage. So minus of that voltage, that will be minus 6. Why it is minus 6? Because this is negative here at this point, divided by resistance. So now the next step is to substitute the value of I1, I2, I3 in your equation 1. So I1 is 12 minus VA divided by 6. I3 is VA. This minus will become plus. Plus 6 divided by 2 is plus I2. I2 is VA divided by 4. So now you have to solve this equation. So solving this equation, so this is 6, 12 minus VA plus 6 times 2 plus VA divided by 4. So we have to make this denominator common. So this was 4. So I will multiply this whole thing with 2 here and multiply 2 here to get the common denominator so that we can solve. Now further, you will solve it further. So it will be 12 minus VA divided by 6 is equal to 2 VA plus 12 plus VA divided by 4. So this gives you, let me pick the second page. That is 12 minus VA divided by 6 is equal to 2 VA plus 12 plus VA divided by 4. So this gives you 12 minus VA divided by 6 is equal to 3 VA plus 12 divided by 4. So you cross multiply to solve it further. So 4, 12 minus VA is equal to 6 times 3 VA plus 12. So you solve it further. 48 minus 4 VA. 6 times 3 is 18 times VA. Minus 17, 18 plus 4 VA. VA. So solve for it. 48 minus 72 gives you minus 48 so from here I got VA as minus 24 divided by 22. So that gives me 1.09, negative 1.09 volt. So that from here, this means I got the voltage value here as VA as negative 1.2. So if you see this one, so we got negative 1.09 as VA. So if you put in this your here, so VA, we got it. So if I have to find current in the individual branch, we already found the value of VA. We solved it and we got negative 1.09 volt. You substitute the value of VA that we got it from here and you will put it in these equations. So I1 is 12 minus VA over 6. So substitute the value of VA in I1. So I will solve it here. I1 is equal to 12 minus 1.09 divided by 6. That gives me 0.18. So I1 is 2.18 ampere. So I got current in 6 ohm resistor as 2.18 ampere. Then find I2. Substitute the value of VA in this equation to find I2. So that will be minus 1.09 divided by 4. That gives me 1.09 divided by 4. That will be minus 0.27 ampere. Then I3 will be, you substitute the value of VA in this equation. So you will get I3 as minus 1.09 plus 6 divided by 2. So that gives me 6 minus 1.09 divided by 2, 2.45. So this is how we have found the currents in each resistor or in each branch using node analysis. Thank you.